Greetings everyone, you are welcome to Jewel's Study World. Today our lesson will be on Introduction to Valence Bond Theory. Valence Bond Theory is a new topic to us, but it is not that difficult. You have to pay attention and concentrate. So let's begin. So before we begin, we have some points that you have to note. So point number 1 is that a covalent bond is formed by overlap of atomic orbitals where atoms are close to each other. So we have already learned about a covalent bond, and we know that the atoms that form a covalent bond overlap with each other because they share electrons. For those atoms, they have to share electrons to become stable. So they will overlap with each other. So it will be something like this. Atom A overlaps with atom B for them to share electrons so that they become stable. And now point number 2. We are saying that orbitals overlap only when the orbitals are half filled and also the electrons have opposite spin. So we are saying that orbitals can overlap only when the orbitals are half filled and also they have opposite spins, or the electrons have opposite spins. So here it means that we have 1s orbital here and then 1s orbital here. For these two orbitals to overlap, so you have this and this. This 1s orbital has 2 electrons and this 1s orbital has just 1 electron. And the rule is saying that for them to be able to overlap, they have to be half filled. So it means that these cannot overlap. So now we have 1s here and 1s here. So now they are half filled, but yet still they can't overlap because the rule says that the electrons must have opposite spins. So these two, they can't overlap. So now we have 1s here and 1s. So you have this and this. Now these two orbitals can overlap because they are half filled and now they have opposite spin. So now this is the requirement. Let's continue. We also have the strength of the bond depends on the amount of overlap. The strength of the bond depends on the amount of overlap. Note that for overlapping orbitals, they form a covalent bond. So we want to know how much strong the bond is. So now we are saying that the strength of the bond depends on the amount of overlap. So it means that we have this bond and then this bond. So we are saying that this bond is weak and then this bond is strong. The reason why this bond is weak is that the amount of overlap is very small. If you look at the distance between them, it's very small. So this makes this overlap very weak. And now this one is a strong overlap because the amount, or it's a strong bond because the amount of. So if the bond is a strong bond, then it means that the bond length will be very small, and the bond energy, which is the energy required to break this bond, will be very strong, because if the bond is very strong, it will require much energy to break these bonds, and that energy is called the bond energy. And now we have 2 types of overlaps. The overlap can either be head-on or axial overlap, and also side-by-side or parallel or lateral overlap. So we have 2 types of overlap: the side-by-side or parallel or lateral overlap, and also the axial or the head-on overlap. So let's first take the axial or head-on overlap. So we have 2 types of overlap. the axial or head-on overlap, and also the parallel or side-by-side overlap. So let's first take this one, the axial or head-on overlap. So this one, the overlap will occur at the lobes, or they will overlap on the same axis. Like we have this orbital. This orbital will overlap with this orbital. So you see, they overlap head-on. Their heads will overlap, and they will overlap on the same axis. That's why it is called the axial overlap. And this axis is called the internuclear axis. Is the internuclear axis. So they lie on the same axis. And now they overlap head-on. It can also be like this. You also have this. The same situation. They overlap head-on. So now we have this here on the same axis. So it's an axial overlap. So this is an axial overlap. And for axial overlap or head-on overlap, they are called, the bond that is formed is called sigma bond. It's called the sigma bond. The sigma bond. So here's the symbol for the sigma. It's something like this. The sigma bond. So for axial or head-on overlap, the bond form is called the sigma bond. And now for parallel or lateral or side-by-side overlap. Parallel overlap or side-by-side overlap or the lateral overlap. So you have the parallel or side-by-side overlap. So for this one, they will overlap side by side or laterally. So we have this orbital here, we have this orbital, and they will overlap with this orbital. So now you see they overlap laterally. They all have their axis. This has its own axis, and then this has its own axis. So this is not an axial overlap. So this is a parallel or lateral overlap. It can also be like this. This is also a lateral overlap because they have their own axis, and now they overlap laterally. So this is also an axial overlap. And for axial overlap, the bond form is called the pi bond. Pi bond. The symbol is the pi bond. So you have the pi bond and the sigma bond. The sigma bond is for head-on overlap, and the pi bond is for lateral overlap. And now let's note this one too. So overlapping orbitals must have the same sign. They must have the same sign, as in they must be positive or negative. They must have the same sign. If this orbital is positive, the other one should also be positive. So it must be either positive or negative. Not positive or negative, or not positive or negative, or negative and positive. They must have the same sign. So let's take the first one for instance, the head-on. So we have this one, this, and this one. They overlap head-on on the same axis. So this one, they are saying that we have plus here, positive, negative. So the orbitals that are overlapping, they must have the same sign. So if here is negative, here should be negative, and then here should be positive. So here, they must have the same sign. Or it may be like this. It maybe negative, positive, positive, negative. So here they must have the same sign. They should not have different signs like this. Like this. So if they have different signs like this, they can't overlap. They must have the same sign for them to be able to overlap. And for the side by side overlap, they must have the same sign like this and then like this. So positive, positive, negative, negative, and now they can be able to overlap. So this brings us to the end of the introduction to valence bond theory. We will begin solving questions on it in our next videos. Like, share, and subscribe to my YouTube channel. Bye.